Yeah, I look at what people are doing now, and I think, have they ever taken a class in linguistics? So in linguistics, you learn about the relationship between syntax and semantics, for example, and between those and pragmatics. And if you build a language production system, for example, in the classic way, you start with a meaning that you want to express, and you translate that into words. Or in language comprehension, you start with a sentence that you want to understand, and you translate that into a meaning. Well, GPT-3 doesn't do that, and people don't even notice that it doesn't do that. What GPT-3 does is it hears a sequence of words, and it predicts the next word. But let's say you want to talk to a user, and you know what you want to say. Well, GPT is like a wild bucking bronco. It's very powerful. It might produce something grammatically interesting, but whether it winds up giving you what you want is an entirely different matter. And if you want to extract from it a model of the world, it doesn't really do that. So there's this paper called Palm Saycan, I think, by Google, where they put GPT-3 in a robot. And it works like 3/4 of the time, and it's amazing. But a quarter of the time it doesn't work. Now imagine that you want to put your grandpa in bed and you want to tell the robot to do that, and 3/4 of the time it does that, and 1/4 of the time it drops your grandpa. Like, this
Right.
is not good.
Yeah, we
Right.
don't want any dropped grandpas around.
So, cognitive science tells us that we want, for example, it's just a basic thing, but you want to map a meaning onto a sentence or the other way around, and people are like, I've got all this data, I don't need to do that. Well, no, you really do still need to do that. Another example is we have lots of knowledge. You go to college and read books, or when you're 5, you read books. You absorb verbal, symbolic knowledge from the world. And there's this funny politics that goes back 50 years about using neural networks versus a knowledge-based approach. And it turns out the knowledge-based approach has some value, but it had some trouble, 30 years ago. So now we're doing all this stuff without knowledge, which means like you have all the knowledge in Wikipedia, and nobody really knows how to put it into these systems. And because they're statistical mimics, you ask a question like, who's the president of the United States? And they might say Donald Trump, because in their data set, there are more examples of Donald Trump than Joe Biden. Whereas you want to be able to reason and say, well, Biden is now the president, Trump was the president before. You want to use your understanding of sequences of events and time. And cognitive scientists think about this stuff. They talk about things like discourse models, putting together what it is that we're talking about, how we're talking about it. So there are lots of ideas. Another one that we didn't talk about yet, but which I learned from Noam, and which is really foundational, I know he learned it from Plato, is innateness, the idea that something is built into the mind. There's lots of reason to think that when we learn language, we're not starting from a blank slate. Noam has made this argument for years and years. I think it's still true. And the failures that we're seeing, for example, with DALL-E, and I'll tell you about one other, are showing you that if you start with a blank slate that just accumulates statistics, you don't really understand language. The myth is always the right things will emerge, which is kind of magic. It's like a Latinate word for magic. It will emerge when you give enough data to these systems that they will understand the world. So we built a benchmark based on what 10-month-olds do in the lab, or 4-month-old for some of the experiments, understanding basic physics, like things drop, or if they're hidden, you can still, find them eventually. And these systems don't understand at all. Children seem to have probably an innate sense of how objects exist in the world. Like, we don't start with nothing. Kant said we start with time and space and causality. He's probably right. We probably start with those things. And over, people keep pursuing this hypothesis that ignores the cognitive science around that and says, we'll just use all the data. And because it works like 75% of the time, they think they're making progress. But sometimes you make progress 75% of the way, it's not enough. We saw that in the driverless car industry, right? Getting close doesn't really seem to solve that problem. And that's what we're seeing here.